This is the introduction video for Homework 10, completing the square and graphing quadratic equations. The learning outcomes for this homework assignment are to solve quadratic equations using completing the square method and to graph quadratic equations that may be given in different forms. First, let's review solving a quadratic equation in the form of the quantity x plus 3 squared is equal to negative 49. In this equation, we will use the square root property and take the square root on both sides of the equal sign. This will create the new equation of x plus 3 on the left is equal to plus or minus the square root of negative 49. Simplifying the radical, we find x plus 3 is equal to plus or minus 7i. We solve for x by subtracting 3 to both sides of the equal sign and get x is equal to a negative 3 plus or minus 7i. Note that this represents two answers, one of them being x is equal to negative 3 plus 7i, and the other is x is equal to negative 3 minus 7i. When we talk about completing the square, we mean we are completing the perfect square trinomial. So we want to create a quadratic expression that looks like x squared plus or minus 2bx plus b squared. First, we will create the situation of x squared plus or minus 2bx, and then we will find b squared by having the coefficient of the middle term, in our case the 2b, so half of 2b is b, and then we square the b, and that's how we find b squared. Here are the formal steps on how to complete the perfect square trinomial. Your book may state 5 steps, as they assume you know that you need to solve for x at the end. The first step is to get 1x squared. The first example video about completing the square that I ask you to view will have the case in which x squared will have a coefficient of 1, while the second example video will have the case in which the coefficient of x squared is not 1. In this second case, you may need to divide the entire equation by the coefficient of x squared. The next step, step 2, will be to get x squared and the x terms to be on the left side of the equal sign and constants to the right side of the equal sign. Do this by adding or subtracting a number to both sides. Step 3 is the actual completing the perfect square trinomial part. We need to add b squared to both sides, and we find b by getting half of the coefficient of the x term. So if the x term is 8x, half of 8 is 4, and 4 squared is 16. We would add 16 to both sides of the equation. Step 4 is to factor the left side and to add the numbers on the right side of the equal sign. When we finish this step, we will have the quantity x plus b squared is equal to some number. And we reviewed how to solve this at the beginning of this video. So step 5 is to use the square root property and square root both sides of the equation. Don't forget to use plus or minus on the right side of the equation. Finally, step 6 is to solve for x. The other learning outcome is to graph quadratic equations. There are two big different ways of graphing. First is by finding and plotting points, and the other method is by using our knowledge of parent functions and transformations. I will use a combination of these methods by finding the y-intercept, the x-intercepts, and the vertex, which are points, and by using the axis of symmetry, which I will call the AOS. First, let's review what these items, the y-intercept, x-intercept, vertex, and the AOS, look like on our graph. Let's look at the graph of y is equal to the quantity of x minus 1 squared minus 5. Here is the y-intercept, here are the x-intercepts, this is the vertex, and this is the axis of symmetry. Now let's talk about the different forms of quadratic equations and what information they can supply for graphing. Here is an example of a parabola represented by these 3 equations. The first equation is in standard form. F of x is equal to negative 2x squared plus 4x plus 6. This form will easily give us the y-intercept. For when we let x equal to 0, we can see that y is equal to 6. So the y-intercept is the point 0, 6. The second equation is the first equation, but in factored form. Notice that each factor is prime and cannot be factored further. This form is also known as the intercept form because we can quickly find the x-intercepts for our equation. In our case, when y is equal to 0, we can see that the x-intercepts are located at x is equal to -1 and at x is equal to 3. So the x-intercepts are the points -1, 0 and 3, 0. Finally, the last equation is the same quadratic equation as before, but in vertex form. This form is found by using completing the square. From this equation, we can quickly find the vertex of our parabola. From our knowledge of parent functions and transformations, we see that the vertex is located at the point 1, 8. Another useful bit of information when graphing is the axis of symmetry. Regardless of how the quadratic equation is represented, we can find the AOS. If we have the standard form, we find the AOS by using the formula of x is equal to -b over 2a. If you have the intercept form, the axis of symmetry is located right between the two x-intercepts. And if you have the vertex form, the AOS is the x-coordinate of the vertex, or x is equal to h. Lastly, I will supply a video that goes over graphing example number 1 the way I would go about graphing quadratic equations. But the textbook supplied video will also be available if you think you need to see another way of graphing quadratic equations. This concludes this video.